Hey, this is Horner, and this is our last question. This is number 4. We've got two elastic strings of identical length. They're connected together at point X. But notice that they are different in that this one is thin and this one is thick. So this is where we have the reflection or the transmission of a wave from a thin to a thick rope. When we do this, they say this after picture shows a full cycle wave appearing on this side. Should this wave have a greater wavelength or a shorter wavelength in the after picture? This one actually should have a shorter wavelength. So the denser string does slow the wave speed. And because of that, the frequency is the same for the wave. And if that frequency is constant, that wavelength has to be smaller, and that's because the wavelength is equal to the speed of the wave divided by the frequency. So another student is looking at that after picture saying, there's more than one aspect of the picture that needs to be corrected. So in a well-organized paragraph length response, we have to figure out what those features are and then figure out how to fix it and give physical reasons for our correction. So the heavier wave here in this heavier string should be closer to the X, okay, because it's much slower. So instead of where it's at, they probably need it to be over here, a little bit closer. And both wave pulses should have a shorter amplitude. So let's go ahead and do some corrections on these. You can do this on the AP test, but you're probably going to need to use a dotted line or something like that. So this should be shorter, okay, just like that. And then this one should be shorter, but be over here. And so you kind of maybe would see something like that. Energy should equal energy out. So energy in should be equal to energy out. So the wave energy, the initial wave, is shared between those two waves, and that's why that amplitude needs to be less in those. And that is the end of that very short 7-point problem.